So, hello, we are the team number 6 from the group 323. The team members are Cecia Contreras, Marcelo Garza, Emilio Gutierrez, Isabela Herrera, and Dominica Marin. We are going to start with the introduction. What is a hydrophobic plant? Hydrophobic plants are those that have developed adaptations to resist water. These adaptations are often manifested on leaf surfaces, where hydrophobic properties repel water. This phenomenon is crucial for the survival of these plants in specific environments, as it allows them to conserve water, reduce nutrient loss, and withstand adverse climatic conditions. These plants often inspire research in biomimetics to develop technologies that might make their hydrophobic properties with applications in various fields, such as agriculture and materials design. In this project, we made a plant based on water and nutrients to experiment what a hydrophobic plant is. We did it in a plastic bottle. What we planted was a lettuce and we oxygenated with a balloon and air. To oxygenate it, we used a straw so the air could blast through and so the bubbles would form, and so we will know that it was getting oxygen. We did this project to test if hydrophobic plants really work to conserve water, for self-cleaning, and to have resistance to adverse conditions.
Process of construction. First, we took an empty gelatin container and with the tip of a hot glue gun we made holes on it. Afterwards, we take a bottle and cut it off from the top. The cutout had to be the size of a gelatin container we used previously. After that, we checked that the container fit well in the cut made, and yes, it did fit well. Then we needed to make a hole through which we were going to oxygenate the plant. We used a knife and the tip of a silicone gun to help us. Next, we decided to change the bottle since we believe it will be easier and more comfortable for us to do the experiment, and we did the same process as before. These are the materials we used to plant the lettuce. And we took previously pierced container and put the lettuce with the live root, and then we put some rocks on it and put it back in the bottle. After that, we fill the bottle with water and put the straw through which we are going to oxygenate the plant, and the final result is on the image there.
I'm Dominica and I'm gonna explain the binnacle from day 1 to day 6. We think the first day of our plant was when it looked the best. That day, a member of the team was in charge from removing the root from the lettuce we bought to later plant it with stones, and that day we only took care of it and oxygenated the water. The second day, the leaf began to fall a little. We oxygenated the water and the roots looked the same as the day before. On the third day, the leaf continued to fall, but it was still stable. We oxygenated the water in the morning and in the evening, and the roots looked the same as the first day. On the fourth day, the leaf continued to fall, becoming more fragile, and it began to lose its green color a little. We oxygenated in the morning and in the night, and the roots looked exactly the same as the first day. On the fifth day, the leaf continued to fall. However, this time it falls completely. We oxygenated the water 2 times a day, and the roots maintained the same. On the sixth day, we continue oxygenating the water day and night, and the leaf falls completely, becoming weak, and the roots started to look a little bit different.
Hi, I'm Cecia Contreras, and I'm going to continue explaining the pinnacle from day 7 to 14. So, on the 7th day, the leaf shrunk completely. We believe that the weather conditions influenced it, since the temperature dropped drastically. Its roots remained the same, oxygenated at night. On the 8th day, the leaf remained the same, that is, wrinkled and small. Its roots remain exactly the same, oxygenated in the morning and night. On the 9th day, the leaf stops being light green and begins to turn dark green with brown. Its size persists, oxygenated in the morning and night. There is no change in the roots. On the 10th day, we observed that the plant continued to become small and turning dark in color. The roots did not change and it was oxygenated during the morning. On the 11th day, we observed that the leaf turned completely dark brown or black, except for the beginning of the leaf. Again, the roots did not change and this time it was oxygenated during morning and night. On the 12th day, we saw how the leaf continued to shrink. We believe it was due to the low temperature. There were no changes in the roots and they were again oxygenated in the morning and evening. On the 13th day, we saw how the leaf lost its leaf-like appearance and began to look like a worm. The roots remained exactly the same as the previous day and were oxygenated again in the morning and evening. On the last day, we can conclude that the leaf almost disappeared. The color became completely dark. It was oxygenated in the morning and there was no significant change in the roots.
Hi, I'm Marcelo Garza, and I'm going to read the conclusion. The gradual deterioration of the plant, marked by the wilting and discoloration of the leaf, suggests a series of challenges in its hydroponic cultivation. While the initial days showed promise, subsequent days witnessed a decline, possibly influenced by factors such as weather conditions and root changes. Consistent oxygenation did not prevent the plant's decline, pointing to potential issues in nutrient absorption or overall environmental conditions. Analyzing and addressing these factors will be crucial for future hydroponic endeavors, emphasizing the need for precise nutrients management and environmental control. Thank you, and Marcelo Garza.